Hi everyone, my name is Sophie. Thank you so much for joining me today. You are here for our ATAR Notes HSC Standard Maths July lecture. I'm super excited to be here with you today. This is a pre-recorded lecture, so unfortunately I can't see your comments in the chat, but I'll get to you in a second about how today is going to work. Firstly, let's have a quick chat about who ATAR Notes is. ATAR Notes are the people on my shirt, they're the people I work for. People who pay me to be here for you. We are a nationwide company who support high school students across the country in terms of their achievements within the ATAR program. So we focus on providing a bunch of different resources. We have free and we have paid. I'll show you what that looks like now. In terms of our free resources, we have hundreds of downloadable study notes. We also have lectures that we run 4 times a year. They run in January, April, July, and September. You're obviously in our July lecture series. We currently have the lectures running 2 hours pre-recorded with a live chat. If you haven't registered for the rest of the lectures on this week, definitely do so. They are super helpful. We have discussions that are held through an online Q&A. We also have videos that are engaging online revision to help keep you focused while you learn, newsletters to help you stay in the loop as to what we're offering and also what's going on with the different syllabuses and how the HSC is updating. We have an ATAR calculator so that you can see if you're on track. We also publish articles that have study strategies and tips that are super helpful. If you're looking for anything else or any of what I've just mentioned, go to atarnotes.com/register. For some more resources, these are our paid resources. The first one, who I work for, is TutorSmart. We are a tutoring company. We provide 2 different forms of tutoring. We provide 90-minute weekly classes. We have one that I run for the HSC Standard Maths course. The class runs from 6 to 7:30 on a Monday night with me and my students, and we work through problems and slideshows and worksheets and trial exams and a bunch of different things with me providing you all the resources in the class through a portal that you can contact me on. We can collaborate. It's a super great environment. That is through TutorSmart and that is paid. We also provide private tutoring which run in hourly sessions. You can do those weekly, fortnightly, twice a week for any of your subjects that you'd like. I'm super flexible in what I tutor with. If you're looking to book tutoring for pretty much any subject, we do offer it. Me personally, I tutor English, maths, modern history, history extension, society and culture, basically any humanity I can help you out with. Study guides, we have printed revision materials and these have top tips to help you get great marks. If you're looking for these in physical form, you head to our bookshop. If you're looking for these in digital form, that is where Ed Unlimited comes in. Ed Unlimited is great. Our private tutoring actually includes an Ed Unlimited subscription. So not only are you paying to have your hour private tutoring, but you also have access to our entire Ed Unlimited suite when you sign up for private tutoring. We'd also like to give a special thanks to our sponsors who help us hold these lectures for you: La Trobe University, RMIT University, Deakin University, UTS, and Macquarie University. Thank you so much. Okay, so how does this lecture work? This is a pre-recorded lecture with a live chat. The lecture will run for 2 hours. You can ask a question by using the chat at any time. I am in the chat right now, not me right now. I am in the chat when you are watching this lecture. Sorry, I know that it makes sense. I'm overcomplicating it for you. I'm in the chat. I will answer your questions. Me right now, I don't know what you're asking. Not sure yet. The lecture hasn't even gone live. So you will need to wait on me to type you back an answer. If it takes me a minute, I'm sorry. There's a couple of different things that I have to do at once. So if I'm not getting back to you, just hold on. I will get to your question. If you see other questions that you also would like answered, then probably don't ask it again, because you will all see the answers for every question. So if someone asks, where do I find past papers, and you want to ask the same thing, just wait for that first person to get an answer to their question. I would also recommend downloading the slides. You can do this at any time, and the video will also be available after the lecture on this webpage. So once the 2 hours is up, the video will not disappear. It will still be available. Okay, so what topics are we covering? The first thing we are going to cover is present and future value annuities. This is from the financial maths topic. The second thing is the sine rule, the cosine rule, and bearings from the measurement topic. The third thing we're going to cover is the shortest path, minimum spanning trees, and maximum flow, minimum cut theory from the networks topic. So we're kind of breaking down networks into 2 sections there, where we're going to do annuities and trig to start, and then we're going to do all networks for the second part of the lecture. This is what our breakdown is going to look like. I'm going to tell you a little bit about me. I'm also going to tell you how I think studying is best done when it comes to maths. We're then going to have our first content block, which was financial maths and measurement, and then our second content block, which is going to be networks, and then we will wrap up and I will kind of do a little chat at the end about all the tips that I find really helpful and would really recommend that you use in the next 6 months that you have left. Not even 6 months. July, August, September, October, 4 months. Okay, so a little bit about me. My name is Sophie. In the chat, you can call me Sophie. Just do not call me Miss. That always really freaks me out because I am within a few years. I'm 20, so we're essentially the same age. I do not know much more than you know about the world at this point. I graduated in 2020 from Bethany College in Hurstville. I got an ATAR of 95.6. I studied English Advanced, Standard Maths, Studies of Religion 1 unit, Modern History, History Extension, and Society and Culture. I also did English Extension until June of Year 12 and Ancient History in Year 11, for some context. I loved my subjects, and you will notice that maths is the sneaky standalone one there. It is the only one that was not essays on essays on essays on essays. It was also the one that I marginally got the highest mark in. I think it was my best subject by 1 mark. I got a band 6 in it. I can actually tell you how that broke down because a lot of students ask questions. They go, okay, but how? I don't understand. Where do you get the marks? Was it from your internals, externals? How did you end up getting that mark? I can tell you because it is screenshotted in my phone. My exam mark for standard maths was 93. That was the exam I actually sat. In the HSC, I got a 93. And then the mark that I got internally was a 92. So it ended up being my best mark, being a 93, which was a band 6. But I was very lucky. Just for a little bit of context, not to scare you off, but I managed to get band 6s in all of my subjects except one, and those band 6s were 90, 92, 92, 93, and then I did 2 1-unit subjects, so a band 6 is a 45, and then in my other subject, I got a 44. So it was 1 mark off, and weirdly enough, when I realized, I did not care because I was just glad it was over. But if you want, interestingly, kind of the breakdown for that, standard maths 93 for the exam mark, 92 for the assessment mark, 93 overall, which is nice. They scale you up. How lovely. I know that a lot of people are scared about the scaling when it comes to standard maths, but if you do well, obviously it doesn't impact you at all. It's more if you're hovering around that kind of lower 80s, 70s zone, I believe. So that is my HSC experience. Where am I now? I'm now studying a Bachelor of Arts and Laws at the at UNSW, the University of New South Wales. I am majoring in politics and international relations and minoring in global development in my Bachelor of Arts, and my law degree is just a law degree. I started there as soon as I finished high school in 2021. I started in the beginning of 2021, and I will probably finish at some point in the future. I think like 2026. We'll see. What year is it now? Yeah, somewhere around there. Who knows? It takes a while to finish these degrees. I love what I study. I am very, very happy in my choice. I love my university and I love what I'm doing. If you have any questions about how I ended up where I did, because it's a very long-winded story, I did not go into law from high school. I didn't do law. I didn't do legal studies, and I didn't apply for law. I didn't do law for a year. I transferred into it after I decided that I did want to study it. If you're interested about kind of how I got into there, I didn't even start in a Bachelor of Arts. I started in a whole nother degree. You can ask me questions about that in the chat, and I might talk about it shortly at the end to give you kind of an idea, now that you're thinking about university, of how many different pathways there are. I have a beautiful German Shepherd named Luna. She will make some sort of auditory appearance at some point in the lecture. I'm sure she will bark. It is just a matter of time. I think she has a sixth sense that she knows when I'm tutoring or I am lecturing, because she always makes a noise. I'm trying to get up a photo of her so that, I don't know if you can see that, so that you don't get angry at her when she barks. She's very beautiful. She will bark. This one I'm second guessing. I think I need to start removing this from my slides because I think it exposes me more than it helps me. I would say that I'm a teacher's pet in a cool way, but in high school, I don't know if you can say in a cool way though. I'll say it. But I was definitely someone who cared. I loved my teachers, I put in effort, and I did the work. And that's kind of not to sound braggy and to sound like, an idiot. But I'd like to say it because I think something that we often overlook as tutors and lecturers is we are obviously the people helping you, and we are obviously the people with the expertise to do so. But it means that you're hearing the same things all the time from people who got really good marks. And I acknowledge that my marks didn't always come from explicitly hard work. They did a lot of the time. I definitely worked hard, but a lot of people who get good marks have kind of academically excelled or done quite well for a long time. So it's not always about the same challenges for every different student. Some students are just trying to understand a concept, while some students are trying to get from a 97 to a 98. They're very different challenges. So I want to add in, yes, I worked hard, but there are certain things that have been something I've excelled at personally, academically, that I understand is not always something people excel at. I just like to put that in there. It's not in a way to sound braggy or to sound like I did so much better than everyone else. I didn't. My ATAR is not unattainable by any means. It's not a 99.95. I think there were maybe 10 people at my school who got higher than me. It's not something that is unattainable, but it is something that I did work hard for, but also is something that I was probably able to achieve based on my experience in academics. It also depends on where you go to school and how, the quality of your education, and also what goes on in your personal life. So there's a bunch of things I want to add in there. Point I'm coming back to is I loved my teachers and I worked hard. And if you do too, don't let anyone make fun of you for it. Something to be proud of. I guarantee that I procrastinate more than you. I will explain this at length if you would like me to. I have a bunch of tips for procrastination that I would love to give you. I'll probably do that at the end. One of my non-academic tips for the HSC, and this is actually good timing for you guys to start thinking about this, is try and plan something. I know a bunch of my tutoring students, I always call them kids. You're not kids. Well, we're all I'm a kid at this point. My tutoring students have all booked really, really exciting stuff, lots of which is not expensive at all. So I really recommend trying to do something. I went on a camping trip. It was so memorable, so incredible. I remember being so excited to go on it. And honestly, it really kept me going. I remember being really, down the dumps about having to do the HSC, really bummed about it, just because I can't sit still for 3 hours. And I was kept going by the fact that I had this trip to go on, and I remember being so, so, so excited for it. And it is still probably the best 4 days of my life. Not kidding. There's probably been some good ones since then, but it was incredible. And I would really, really recommend doing something like that if you can. Okay, so how the hell do you even study for maths? Okay, I don't want to freak you out. Trials are coming up in a month. So you do kind of need to start now if you haven't started. If you have, amazing. But start now in terms of not just doing your homework, but studying, practicing the things you don't understand, doing past papers in your free time. Free time is limited, I understand that. Making time to do past papers. Keep a rule book. If you have not already started a rule book, that's fine, but you need somewhere that you're recording stuff that isn't just you doing questions. I know that my maths book was kind of full of me just doing questions, writing notes, making tips for myself, but I kept summary sheets for every unit. So there were 5 units, which were broken down into 10 chapters in my textbook. I had 10 summary sheets as a result. So I had a summary sheet for every subunit. So say networks, which has 2 sections to it, I had 2 summary sheets, one for network concepts, one for critical path analysis. It's very important that you break down your work into summaries and not just going from your book, because a lot of the stuff that you keep in your book is not stuff that you actually need to know. No, it's not about memorizing how to do questions. It's about memorizing the rules and the formulas. All right, another very important thing to focus on is to figure out what you need help with and to target it. Spend a little bit more time on the things that you struggle with, but don't disregard everything. If you've attended one of my lectures before, you've probably heard me tell this story. I feel like I should stop telling it because I come across as a massive nerd. And you know what? At this point, own it. Like I work for a tutoring company. But I remember in year 12 that I really, really, really did not want to do bearings work. I hated bearings, and I still do, to be honest. I really didn't want to do bearings and trig. but I really kind of was getting good at simultaneous linear equations. So I used to sit there and do simultaneous linear equations instead of doing bearings, because I thought, well, I'm studying, but I wasn't. I was just repeating something that I was already good at and not studying for the thing that I didn't understand. So very, very important is to please focus on the thing that you do not understand and that you need help with, and target it. It's like your body trying to fix an infection. It's not going to focus on, I know nothing about how our bodies work. It's not going to focus on, fixing a scab on this arm that doesn't need to be fixed when this is the one that has the scab on it. I'll go with that. Okay. Know that there is always someone who can help you. The first thing out of your mouth is, yeah, but my teacher's not very good. Okay. First things first, teachers catch a lot of flack. Second thing, I do understand that sometimes teachers can be a little bit difficult in getting your questions answered or in feeling like you're getting the help you need. So firstly, if you have amazing teachers like I did, squeeze them like a sponge. Take all the knowledge from them and put it into your brain. Take everything you can from your teachers within reason. They're being paid to help you. Ask them as many questions as you can. Email them within reasonable hours and not on weekends. And take them work that you've prepared your answers to. So don't just be like, can you do a question with me? That's fine, but at least bring them a question. Be helpful, but get them to help you. If your teachers are not able to help you, go to your peers. If you don't understand something, hopefully someone in your class does. After that, parents, maybe depending on how much maths has changed since they went to school. The next resource, which I would obviously advocate for, is tutoring or ATAR notes. TuteSmart, we are being paid to help you out. We are very passionate about your learning. I care a lot about my students. I really do want them to succeed, and that hour we get a lot done. I think it's worth it. You can also come to ATAR notes for some free resources, and there's a million YouTube videos and resources online that can help you learn how to answer questions. This one is a yes and a no. So I do think studying with friends is great in the sense that they're going through the same thing as you. They're the only people who understand how it feels. I know that I did it 3 years ago, but it's starting to fade, honestly, the memory. And I remember it being stressful and fun and memorable and tiring. And I don't remember much more than that. So if that's any consolation that it will one day just be a foreign memory, then that's nice. But I think studying with friends is good in the sense that you help each other, but it's not great in the sense that it's a very, very easy way to be distracted. This is where you need to be responsible and you need to be kind of disciplined with yourself and be someone who pays attention to the way that in which you work. If you are a student who gets distracted very easily and should probably not study with your friends, then do not study with your friends. I do this all the time. 2 of my uni friends and I are competing in a competition together at the moment for law, and we even though we knew yesterday that we all had the same gap between classes free and we could have worked together, we agreed not to and to go and be separate because we knew we wouldn't get anything done. So sometimes you have to be harsh and you have to be real with yourself and say, I'm not going to do anything. Although sometimes those days before the HSC where you just go to the library and you just hang out with your friends and you don't really do anything, I think they're actually just as helpful as studying sometimes. You need a little bit of a break, obviously. There's also no harm in helping others. The better that the person next to you does, the better you do. The final thing that I say, and then you all scoff at me and go, well, I can't do that. I know, but you do need to try and take care of yourself. These next couple of months are going to be very intense academically. You really can't neglect your physical and mental health. It will happen, honestly. I think physical health goes out the window. There's no time to exercise. Food, if you are someone who, enjoys a nice meal, probably start, not eating as well. And then mental health, obviously, it's very stressful. Do as much as you can to take care of yourself and listen to your body. I can tell you a little bit of an anecdote just from the last week. I've had a really, really intense week with uni and work, intense couple of weeks, and a bunch of competitions I'm in at the moment, and my body kind of shut down on me. I got a cold. You can probably hear I'm still kind of at the tail end of it. And for a couple days there, not a couple days, but for, a day or so there, I had to really just sleep. I slept in. I didn't do too much during the day. I did, a couple hours of work when I needed to. and I went to bed early. And that has got me back on my feet. If I had tried to work through it, I'd probably be sick for another 3 weeks. That is exactly the same thing as the HSC. I had a curse of always getting sick during exam periods. Genuinely, for 2 years straight, I got sick every exam period. And I think it's because I was probably overworking myself. The other thing is, with a casual jobs are great, but if they're taking away from your ability to look after yourself, then it's probably time to let it go. Let me know in the chat. I want to know what topic you would say you struggle with the most. Is it annuities, trigonometry, or networks? Obviously, I'm not going to respond to you verbally, but I am just interested in what you guys find the most difficult. So, financial maths, annuities, this is our first content block. What is an annuity? Take a deep breath. Take a drink of water before I begin, because this always gets complicated when it doesn't need to be. Okay. What is an annuity? An annuity is an investment account that has regular equal payments made. Interest is compounded at the end of each period. Annuities are calculated in this course, the course I'm talking about, our course, using future and present value interest tables. Or present value tables, sorry. Not really interest tables. Okay, so what does all of this mean? Annuity. An annuity, in simpler terms. Let me draw it out for you. Okay. This is the bank. The bank has my money in it. Let's say this is the person at the bank. This is me at the bank. I'm going to make this as simple as I can because it always gets really complicated. I'm in year 3 again. There's my hair. Okay, this is me at the bank. I'm at the bank. I did really, really well this year and I saved $20,000. Right? I have all this savings left over. What am I going to do with it? All right, let's take $500. I'm going to go to the bank and I'm going to say, hey, I have this kind of money that I want to use in some sort of investment. I'm going to give you guys $500 now this year. And if you're going to pop $500 in the account, the bank goes, yep, we'll take the 500. We're going to pop it into this account. This is the account here. I now have $500 in this account. There is an investment that they're going to place money on to that with. So there's interest. They're going to go, okay, cool. You've given us $500. We are going to give you 5% interest on that. I go, amazing. Thank you so much. That is really, really nice of you guys. I appreciate it. They go, no worries at all. That's going to be $25 every year that we're going to pop onto that account. I go, amazing. At the end of that year, I have $500 plus $25 of interest. An annuity is, in essence, about the regular payment. So then I come back. It's now the second year, the start of the second year. Go, hey guys, amazing job on that. I'm super excited about that $25 I got on my $500. I'm going to add another $500. That's how an annuity works. I now have $1,025. They're going to go, thank you so much. We'll see you back again on the 1st of January next year. They're going to calculate the interest. The interest is going to be added. I'm going to come back at the start of year 3. I'm going to go, hey, here's another 500. I am investing a regular equal payment at the same time every year, every month, every week, every 6 months, every 3 months, every 4 months, whatever it is. I am investing that money, same time, same amount, every time period, and they are paying me interest. We don't work this out using compound interest. We work this out using a table. There are 2 types of annuities, future value, present value. Let's think of it as a timeline. This is us. We are currently, I'll make this really meta. We're currently watching me give a lecture on annuities. This is you watching that lecture. Wow, so interesting. This is where we are right now. You're thinking about investing some money. The future value of an annuity would be if you invested that money today and you're asking me how much money it's going to be worth here in 2025. The present value of an annuity is you saying, I invested this much money. What is the present value of my annuity right now? This can also work as if I invest this much, or if I want to have this much here, what would I need to invest right now? So imagine this timeline when you're thinking about future and present. The actual way of working it out is exactly the same. It's just words. So what is the future value? The future value is finding the total value of an investment after a given period of time. So after we've done all the investing. So we're going to pop some examples in. Given the table below, find the future value if $8,000 is invested half yearly over 4 years with interest compounded at 7% per annum. Okay, this is the future value of $1 in this table. Okay, half yearly over 4 years. Twice a year every 4 years is going to be 8 time periods. Interest compounded at 7% per annum is going to be, is invested half yearly over 4 years, which means that it's happening twice a year. We need to half our interest rate, so 3.5%. So we have 9.052. I'm going to do 8,000 times 9.052, and that is going to give me my answer. We go through here, 3.5%, 9.052, $72,416. So this sounds like a bargain, right? You pop $8,000 in an account, you get 72 grand. No, you've put $8,000 in that account 8 times. Remember, 8,000 times 8 is $64,000. So $64,000 of that money was yours, but the bank has paid you about $8,416. That's a pretty good deal to just pop some money in an account for 4 years. So it's important you think about the amount you've popped in and the amount of interest you've earned. So given the table below, find the future value of $8,000 is invested. That was our question. What if you were asked to find the amount of interest? We already know that including interest, the answer was $72,416. Without interest, we simply need to take the amount of money we added, which was $64,000, and subtract that from the amount that we actually received. With that, we get $8,416, like I said. All right, so we're going to work through these a little bit slower so you can do them at the same time. Given the table below, find the future value if $12,500 is invested 3 times a year for 2 years with interest compounded at 12% per annum. First thing is our time period. 3 times a year for 2 years is going to be 6 time periods. We now need to change our interest rate. 3 times a year, but this is per annum. We need to divide this by 3, which becomes 4%. We now have our intersection, 6.633. All we have to do is take our value, 12,500, pay attention to the actual heading. This is the future value of $1, so we can take the full value. 12,500 times it by 6.633. Once we do that, 12,500 times 6.33, I get 79,125. Okay, we've also, we'll get the answer here, yep, 6.633, 83,287 point. Oh, I missed a 6 in my answer. Apologies. Yes, that is correct. 6.663. I wrote 6.633. There we go. $83,287.50. So what I wrote back here, this, see how I wrote that incorrectly? 6.6. Oh, the answers used the wrong number. Okay, my original answer was correct. This needs to be a 3. Always important to check your working. Obviously, we still get it wrong ourselves. Okay, that was future value of an annuity. What is the present value of an annuity? This is the present value, the whole sum of money that could be invested today at the same compound interest rate as the annuity to produce the same future value over the same period of time. So essentially it's saying, I want this amount of money. What do I need to invest today? It's about planning out your investment. Let's say you want to you're going to do Euro Summer in 2025 and you need $30,000 to do that. You're trying to figure out how much money needs to be invested now so that you have $30,000. So let's look at some examples. Given the table below, find the present value if $2,300 is contributed half yearly for 2 years at 16% per annum compounded every 6 months. So let's work through this. Half yearly for 2 years is going to be 4 time periods. 16% per annum compounded 6 monthly. We need to divide that by 2 to get every 6 months. 8%, 3.31. So I'm going to take $2,300 and do 3.31. $2,300 times 3.31. And I get 7,613. So we can work through that the same way. Break this down. There it is, $7,613. All right, now it is your go. We're going to work through these again a bit slower. Given the table below, find the present value if $54,000 is contributed quarterly for a year at 24% per annum, compounded quarterly. Quarterly for a year is going to be, I'll give you a couple seconds, 4 time periods. The interest rate, if it's 24% per annum compounded quarterly, we need to divide that by 4, is going to be 24 divided by 4, 6%. We need to take 54,000 times that by 3.47. 54,000 times 3.47, and we get 18,738. Much simpler, aren't these, than a lot of people think they're going to be. 18,738. Okay, so this is a question from the 2017 HSC paper. A table of future value interest factors for an annuity of $1 is shown. So again, same thing, annuity of $1, so we times by the total amount. An annuity involves contributions of $12,000 per annum for 5 years. The interest rate is 4% per annum, compounded annually. Calculate the future value of this annuity. Calculate the interest earned on this annuity. Okay, we're now going to work through this one together. $12,000 per annum for 5 years. We have a period of 5 years, and it's 4% per annum compounded annually. Therefore, our value is 5.4163. We're going to do 12,000 times 5.4163. 12,000 times 5.4163. And I get 64,995.60. The interest earned on this annuity, we need to find the total amount that we invested without the bank giving us anything. $12,000 every year for 5 years. 12,000 times 5 is going to be 60,000. And this is how I'd recommend working it out on your paper. Then you go 6499560, and you subtract 60,000, and you would get $4,995.60. And there's our answer. Okay, this is a bit of a longer one. The table gives the present value interest factors for an annuity of $1 per period for various interest rates and numbers. R is our interest rate, N is our number of time periods. Oscar plans to invest $200 each month for 74 months. His investment will earn interest at a rate of 0.0080 as a decimal per month. That is 0.8 as a number. Use the information to calculate the present value of his annuity. $200 every month for 74 months. His investment will earn a rate of 0.0080 as a decimal, which is this one. This is our factor. Present value, we're going to take his $200 every month and we're going to times that by 55.68446. 200 times 55.68446. And we get $11,136.89. That's the present value. Lucy is using the same table to calculate the loan repayment for her car loan. Her loan is $21,500 and will be repaid in equal monthly repayments over 6 years. The interest rate on her loan is 10.8% per annum. Calculate the amount of each monthly repayment correct to the nearest dollar. So this is what you can sometimes get. You can get linked questions. Okay, so we have a loan of $21,500. Equal monthly repayments over 6 years. The interest on her loan is 10.8% per annum. So we need to do 10.8% divided by 12, which is 0.9% every month, which is this one here. It is monthly for 6 years. So 12 months every year times 6 years is going to give us 72 months. This is our value. We're now going to take her loan, which is $21,500. And we're calculating her monthly repayment. So what we first need to do is find out the total amount of money that she will be repaying. So we have the interest rate per period, 52.82118. So 52.82118. We're going to times 21,500 by 52.82118. Is that right? Hang on. 52. Oh, no, that's incorrect. Hold on. I just realized, I was like, we can't times the number by something that big. So let's take her, let's divide 21,500 by 72 months. There we go. $298.61. $298.61. Oh, 61 cents. 298.61 times 52.82118, and we get the total amount of each monthly repayment should be, my answer's not looking very correct. Hold on. We should have it here. There we go. Okay. There we go. So that's our problem. We need to divide. I was like, something's definitely wrong. Okay, so let's go back up here. Oscar plans to invest $200 every month. We have our total value, 11136.89. That was all worked out correctly. That was my rookie error in having not done annuities in a while, forgetting that we need to divide if we're looking for our monthly repayment in this question. We're taking our total amount and dividing by our payment, because remember, we're not getting paid this, we're paying this. So let's think divide if we're paying. Okay, amazing. So I want you to pop a number in the chat from 1 to 5. How confident with annuities are you now? 1 being low, 5 being high. Obviously, it's kind of a difficult topic if you don't understand it. I think it gets there in the end, but I'm hoping you're all a 3 or above. If not, that's completely fine. You can come back to these questions when you're ready. Okay. Measurement. We're looking at the sine and cosine rules now. We're going to talk about trigonometry. This is, now reflecting on before, I would have expected that most people would have said trig was their hardest, But it actually usually doesn't go that way. I feel like it's usually more split evenly. I think trig's the hardest personally, but it's only because it's something that I just always had trouble with. Okay, so cast your mind back to year 11. We learned about sin, cos, and tan. We learned about hypotenuse, opposite, and adjacent. We learned about SOHCAHTOA. So I want you to think SOHCAHTOA as existing back in year 11. We don't want to think about that today. We're thinking about year 12, which is the sine rule and the cosine rule. So the sine rule is one way in which we find missing sides and missing angles and triangles when they're not right angled. So we're all in the world of non-right angled trig. All of this stuff you learn in year 11 only applies to right angled trig. All the stuff we're learning today applies to non-right angled trig. So to find a missing side using the sine rule, you need to have two angles and one side already. So first let's talk about how we even label our triangles. All of our triangles are just labeled by letters, big letters and little letters. We use capital letter A, B, and C to highlight or to label our angles. Angle A, angle B, angle C. To label our sides, we label the opposite side to the angle we just labeled with the lowercase. So if this is angle C in this corner, we label this side C, lowercase. If this was angle B down here, we label this side angle B, side B, and if this was angle A up here, this is now side A down the bottom. You can label them all the sides whatever you want, as long as it's A, B, and C. It doesn't matter which one's A, B, and C. There's no rhyme or reason. A, B, C in any order. The sine rule, critically, should have pointed that out, is A over sine A equals B over sine B equals C over sine C. It is on your reference sheet in the bottom left-hand corner. You get 4 things for trig: area of a triangle, sine rule, and then the 2 cosine rules. All right, let's look at some examples. This is a non-right angled triangle. We have been given 2 sides and an angle, and we're being asked to work out the missing side. We're asked to work out side B here. So sine A equals A over sine A equals B over sine B equals C over sine C. Whatever we're looking for is the piece of information that we place on the top of our equation. So if we're looking for a side, we put our sides A, B, and C. That's where we go A over sine A. If we're looking for an angle, we would do sine A over A. The sine is always attached to the angle. You don't switch it, so it's sine side. So we only ever need 2 parts of the equation. We don't need to do all 3. We can do it like this. We can do it like this. We just need 2 parts. We're going to do B, which is the side we're looking for, over sine 34, it's the angle opposite, equals 13, which is the side we already have, over sine 68. So essentially, this equation compares a ratio between an existing side and angle to determine what the missing side must be to the angle that we have. Once we pop all of that in, the simplest way to think about this is simply cross multiply. Just move sine 34 to the top. So we go B over sine 34 equals 13 over sine 68. We simply move sine 34 to the top and we do 13 times sine 34 equals sine 68. And let me confirm with you that that is the correct answer in my actual calculator. It's very important you pop the fraction in. If you don't, it will be wrong. Sine 34, and always put brackets on the end of your sine. Sine 68. 7.8. Yeah, that's still the correct answer to 1 decimal place. You could also write 7.84 if it was not. Okay, you can also use the sine rule to find a missing angle. You simply flip the equation. So now sine A is on the top. So let's say we're looking for theta in this equation. We have 2 sides and we have 1 angle. Importantly, the angles and sides must correspond. So see how this is C, angle C and side C, and this is A, angle A and side A. Okay, so once we get our missing angle, we want to find A. We're going to pop it over the side we have, which is 7.1, equals sine 30, a angle we already have, over a side we already have, 4.8. Again, critically, they must be related to one another. Sine A equals 7.1 times sine 30. Remember our cross multiplication. Move this to the top. sine 30 times 7.1 over 4.8. Now, very, 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 very important. Please listen to me when I say this. If you are finding an angle, you have to hit shift sine so that your sine, I don't know if you can see that, is a -1. If you do not do that when you're finding an angle, it is going to be incorrect. You are not going to get the mark. Boo. Always do inverse sine. This is what we call this. Inverse sine or sine -1, whatever you can use to remember. Sine -1, all of this goes in brackets, which your calculator automatically does. If you hit shift sine, you see that the brackets, I don't know if you can see that, open up, and they automatically become sine -1 bracket. Once you pop all of that in, we get 48 degrees. Now remember, when you find an answer, hit this button on your calculator with the little bubbles on it to get the actual degree. Okay, if you cannot use the sine rule, this is where the cosine rule comes in. So very important, sine rule we're using to find missing angles and missing sides. Cosine rule we could use to find the exact same things. We can still find missing angles and missing sides. Okay, so the cosine rule to find a missing side is c squared equals a squared plus b squared minus 2 times a times b times cos c. One more time. C squared equals a squared plus b squared minus 2ab cos c. This is on your reference sheet in the bottom left-hand corner. If you need to find something using this rule, this involves all 3 sides and 1 angle. You're going to have 2 sides and 1 angle already. Importantly, you must have 2 sides A and B and angle C, which is going to be the angle between them, because if this was side C, this is going to be angle C. See how that's cos C? Because you're looking for this side. So if we had a triangle and this was A, this was B, and this was C, and you were looking for C, and you had this angle and you had this angle, you can't look for C using the cosine rule because you need this angle to find it. That's why it's very important that you check what angles and sides you have. In that case, you would use the sine rule. All right, let's have a look at an example. C squared equals a squared plus b squared minus 2ab times cos c. In this equation, or in this question, we're being asked to find this side, x, which is really side C. But we're going to represent it using x squared. So we have a squared, which was this side, 12.5, plus 9.8 squared, minus 2 times a times b, times cos 23. This is the angle opposite the side we're looking for. Angle C. Once we do all of that, we're going to get a nice big number. C squared equals 26.766. We then go square root 0.766. Square root it. 5.2. It really is 5.17, but we're going to round to 1 decimal place and say 5.2. Okay, so like the sine rule, we also rearrange the cosine rule to find an angle. This is also on your formula sheet. You do not need to remember how to change it. It is the last thing on the left-hand side. Cos C equals a squared plus b squared minus c squared over 2ab. One more time. Cos C equals a squared plus b squared minus c squared over 2ab. So if we're looking for the angle in here, angle theta, we're going to find, or check all of our sides first. We have all of them. We don't need any other angles, but the order is important. A squared, which is this side, 8.4, plus b squared, 4.7, minus 6.8 squared, that's the other side, over 2 times 8.4 times 4.7. Once we do all of that, we need to put it into inverse cos, because why? I'm going to pretend you're saying back to me. Correct. We're looking for an angle. You need to do inverse cos or inverse sine whenever you're looking for an angle. Once we do all of that, I will tell you the answer as it's not on the screen. Hold on 1 minute. Always important, pop the bracket at the end, otherwise it'll give you a math error. And that is 54 degrees. Oh, let me check my degree button. Hold on. Yeah, 54 degrees. Okay, we're going to answer these ones together as well. They're definitely good ones to come back to. Okay, let's have a look. Find side X. This is really side C. We can think of it as side C. Let's just pretend these are all side C. All right, C squared equals A squared plus B squared minus 2AB cos C. C squared equals 12 squared plus 7 squared. We need our two opposite sides. A squared, which is this side, plus B squared, which is this side. Minus 2 bracket 12 bracket 7 times cos 78. Important. When you are finding an angle, you use inverse. When you are writing an angle, you don't need to use inverse. So see how this is just cos 78, or in the sine rule, it's just sine 78. You only use the inverse if you are actively using that function to find the angle, not simply writing the angle out. Once we've done all of that, our answer is 158.071, and we pop that into our square root because we can see that our formula for the cosine rule is starting with c squared. Once we do that, we get C, or side C, equals 12.6. And we want to write kilometers as well. All right, find the missing angle. This is a sine rule question. Sine A equals sine A over A equals sine B over B. We're going to find this angle here, which is angle A, opposite side A. Let's label all of our sides just to help us. We've got a full piece of information here, 34 degrees and 7.6 millimeters. Okay, we're going to pop in sine A, which is what we're looking for, over its side, which is 13, equals sine 34, which is the angle we have, over this other corresponding side we have, which is 7.6. We're then going to move the 13 to the top. 13 times sine 34 over 7.6 is going to equal to, once we pop in our inverse sine, 73 degrees to the nearest degree. Okay, this is a question that we're going to work through together. From point S, which is 1.8 meters above the ground, a pulley at P is used to lift a flat object, F. The lengths SP and PF are 5.4 meters and 2.1 meters respectively. The angle PSC is 108 degrees. Okay, so let's have a think here. Show that the length PC is 6.197 meters, correct to 3 decimal places. Calculate H, the height of the object above the ground. We have a 1-mark question and a 4-mark question. Let's just have a look at our question first. We have a triangle in here. We want to find the height of PC. We're trying to find this length here, PC. So essentially, the first thing I would do is think of this as its own triangle. This is 108 degrees. This is 1.8 meters. This is 5.4 meters. And that is all the information I have. I now need to find, let's call this side C. So this is angle C, let's call this angle A, side A, angle B, and side B. How am I going to find my missing angle? I am going to use the cosine rule for this one. I've got them on my formula sheet. So the cosine rule for finding a side is, remember, C squared. So let's just call PC C for now. C squared equals A squared plus B squared. A squared is going to be 1.8 squared. B squared is going to be 5.4 squared. Minus 2 times A, which was 1.8, times B, which is 5.4, times cos C. Cos C is my angle, 108. Once I pop all of that into my calculator, which I'll do now, We need to square root it all once we're done. So 1.8 squared plus 5.4 squared minus 2 times 1.8 times 5.4 times cos 108, close brackets. Remember, we don't need to inverse it. We get a big number. We get 38.407. I'm now going to square root 38.407, and I get 6.197. We want to go to the nearest 3 decimal places, 6.197 meters. And now we need to calculate h, the height of the object above the ground. This is h. So how are we going to do that? We first want to find, if we think about this logically, what we're actually even looking for here. So we have a triangle that we can pull out here, which we can now draw over here. We have this side, which was, we've just found 6.197. We know that this is 2.1. This is h. This is what we're looking for. We know that this is a right angle, and we don't really know much more than that. So let's go back to our original triangle. What else could we potentially work out from this? Because we're not dealing with right angled, we're dealing with non-right angled. So what are we dealing with over here that we can use to find our edge? Okay, so if we start with our old triangle, going back to here, we can use this information to find the angle that is in this corner. So really, let's call this angle B. So let's go through and find angle B. We're looking for angle B, which is sine B over, what's our side, 5.4. And what's information we already have? Sine 108 over the side we just found, which is 6.197. Once we do all of that and we rearrange our formula, let me figure that out for you. We get 0.8287, which is really once we angle 55 degrees, 58 minutes. So 55 degrees, 58 minutes is this angle in here. Now that we have that, we can subtract 55 degrees, 58 minutes from 90 to find out what this angle over here is. Now, because we figured out that this here is 55 degrees, 58 minutes, if we subtract that from 90, we find that this angle is 34.2 degrees. So work through it methodically. We now know that that is 34.2 degrees. What can we do from there? We can now find the height of the object above the ground by going back to our sine rule and by applying our traditional sine application from right angled trig. So we know that it's this angle we're looking for. Oh, sorry, not this angle. We're looking for this side. So let's do sine. Let's label. We've got hypotenuse. This is going to be the smaller side. So we've got adjacent and we've got opposite. We have information for, let's see, opposite and hypotenuse. So we're going to do sine because we're looking for our opposite, and we have our hypotenuse. We're looking for the total opposite so we can find h. Because we have 2.1, we're looking for this part. So what we're going to do in there is do sine 34.2 degrees. And then we want our opposite over our adjacent, which is going to be 2.1 plus h over our hypotenuse, 6.197. And once we do that, we work out that, so we flip it all around, and we should get 6.197 times sine 34.2 degrees, and that's going to equal 2.1 plus h. So we know once you do all of that, I'm just skipping ahead so you don't have to see me write all the working down. 3.468 equals 2.1 plus h. So all we have to do is go 3.468 minus 2.1, and we get h is 1.368. Thank you for sticking by me with how long that took. Hold on, it's really 1.4. This is just my way of illustrating to you that these questions require long bits of working out at certain points. So that is where we end up. I'm going to give you a second to look at that and pick apart any part that you didn't understand. Okay, great. Let's move on to bearings. I hate bearings. Bearings are definitely not my favorite part of the syllabus whatsoever. I think they suck, but we have to learn about them. They're the direction of one object from another. There are two types of bearings. We have compass bearings and we have true bearings. Today we're specifically going to talk about how we use true bearings and then how they appear in questions. So true bearings in simplest form are measuring the way in which an angle moves clockwise from north. They're always 3 digits. We have an example here. First one, we move from north all the way around clockwise, 3 o'clock, 6 o'clock, 9 o'clock, say that's 10 o'clock. We're 31 degrees from the west line, so we're going to add, it's important you memorize these numbers, 90, 180, 270. If we add 31 to 270, we have a true bearing of 301 degrees true. You always need to write 301 or the number true, and there always needs to be 3 numbers. Let's see how that works with this one. This one, north clockwise, is only 56 degrees, but we have to write 0 beforehand, 56 degrees true. All right, alternate angles. This is important in bearings. They form a Z shape with the transversal. This is the line running between the parallel lines. See how these lines are parallel? This is the transversal. See how this forms a Z. These angles here are the same size. Corresponding angles are on the same side of the transversal, but below each of the parallel lines. They are the same size as well. Co-interior, so co-inhabiting the same interior, both on the same side of the transversal and inside. They're in the same room. They are supplementary, so they're going to add to 180. See how this one is smaller than 90 and this one's bigger? They're going to add to 180. All right, let's have a look at an example. A plane flies for 250 kilometers on a bearing of 48 degrees true, then turns and continues for 385 kilometers on a bearing of 145 degrees true. How far is the plane from its starting point? So we're going to work through this with some drawings. We're first going to pop our north line on. Then you're going to draw in a 250 kilometer line, not really 250, you know what I mean, with a bearing of 48 degrees true. So try and be accurate. You don't need a compass, but try and be somewhat accurate. Draw on another north line. Then we're going to draw in our 385 kilometer, 145 degree turn. That has now created a triangle. These steps that I've just indicated here are something that a lot of students miss. Very, very, very important. The whole point of these questions is turning them into triangles. Once we've done that, we have a 250 kilometer line, a 385 kilometer line. That's the angle we're looking for. We're looking for theta. How far is the plane from its starting point? This is the line we're actually looking for, but step number 1, we need to figure out our angles. So we have co-interior angles here. Think of our parallel lines. We have 2 angles existing here. So 180 minus 48, we know that this angle here is 132. Step 2, we now have this circle here. We have 132, 145, and we have something existing in here, which is theta. We minus 132 and 145 from 360, we get 39. So we now know that that is what our triangle looks like, 39 degrees internally. We can now use the cosine rule if we go back to our angle that we just learnt, and I'll write it quickly for you. Cos C equals a squared plus b squared minus c squared over 2ab. And we end up with 247.23 kilometers. All right, another question. Points A, B, and C are 3 ships. The bearing of A from B is 59 degrees true. The bearing of C from A is 167 degrees true. If AB is 8 kilometers and AC is 6 kilometers, what is the bearing of B from C? First thing, pop our north line on. Next, we're drawing our 59 degree true line from B to A. A from B indicates B to A. Read it always from is the starting point. The second letter is the starting point, not the end point. A from B. Once we've drawn that line on, we then draw on our 167 degree turn, which is 6 kilometers AC. We pop a north line on. Guess what the next step is? Make it a triangle. Once we've done that, we now have identified the bearing we're looking for. The bearing of B from C is starting at C and going clockwise until you hit the B line, which is this line here. We now need to work that out. So fill in all the angles you can. Let's have a look. We can use our co-interior. 59 plus 121 must equal 180. Therefore, we have both angles on the side of our north line there, which means we can subtract 167 and 121 from 360, and we get 72 degrees. We can then pop on 13 degrees for the same reason over here. 167 plus 13 is 180. Now we use our cosine rule to find 8.39 kilometers to 2 decimal places, which is this line here, by using our cosine rule. And remember, that is the side rule. So c squared equals a squared plus b squared minus 2ab cos c. And then we have the sine rule or the cosine rule. Either of them work because we have so much information to find this internal angle, which is 64 degrees, like that. And then we can find the bearing, which is 283 degrees once we subtract 64 from 360. That is how you would do this question. I know it's quite hard to understand when I'm just reading out the working out to you, but in practice, hopefully those steps help you. All right, here's a practice question. Anthony is standing 145 meters due east of the hole at a golf course. On his first shot, Anthony hits the ball 94 meters, but not at the correct angle. On his second shot, he hits the ball 60 meters and gets it in the hole. On what bearing did he hit his first stroke? So we've drawn out our beautiful triangle there. We have Anthony, we have the 94 meter first shot, we have the 60 meter second shot, and we have the hole, and then we know that we're 145 meters from the hole when we first start. We want to find the bearing he hit his first stroke at, which is really this bearing here. So this here, we're looking for this angle. So we don't even have any of the interior angles, and we need to find an exterior. Let's slow down. We can use the cosine rule here to find an interior angle because we have all 3 of our sides. So let's label our sides first. We're going to find cos C. So let's find this angle because we want this internal angle here. So we're going to label this side C. This is going to be side A, which makes this angle A, and this is angle B and side B. Okay, so cosine rule, we're going to do cos C, which is the angle we're looking for here, equals a squared, which is 94 meters squared, plus 145 meters squared, minus 60 meters squared, and we do 2 times A times B. So 2 times 94 times 145. Once you put all of that into our calculator, we get, give me a second, because we have to pop it into cos C. We have to do -1 as well, brackets, fraction 94 squared plus 145 squared minus 60 squared over 2 times 94 times 145 make sure you close your brackets, 15.559. I'm going to hit my bubble button. It's 15 degrees. So I know that that's 15 degrees. We now need to do 90, which is this here, minus that 15 degrees equals, and we're going to get something like 75 or 74, depending on what point you use, degrees, and we can see that there. It's 74.44 degrees true. Remember, we're looking for this angle, which is our bearing of our shot, and we need to represent it as 0.74 degrees true. Okay, that brings us to the end of bearings. We are now into the second content block, which is our networks. We're going to start with shortest path spanning trees, our networks 1 unit, and then we're going to move into networks 2. I've just separated them out into shortest path, minimum spanning trees, and then for the second part, maximum flow, minimum cut theorem, but they're all going to be obviously in the same section. Don't answer a poll. I want you to let me know in the chat, what do you think is the hardest? Shortest path, minimum spanning trees, or maximum flow, minimum cut? Just is interesting to me, and if you have any questions attached to that, again, let me know in the chat what those questions are. Okay, the networks topic is split into 2 branches: networks, network concepts, and critical path analysis. So we have shortest path and minimum spanning trees under network concepts, and we have critical path analysis, which is maximum flow, minimum cut theory. This is all equally tested. It's just split into those 2 sections for the ease of having an understandable curriculum and syllabus. Okay, so the shortest path is a path between 2 vertices in a network for which the sum of the weight of its edges is minimized. Essentially, what's the quickest way or the shortest way to get from one place to another? What is the shortest path from A to B? We have A, we have B. Let's go through 3 different paths. Let's maybe do the first one in red. Our first path would be 4 plus 6 plus 1, and we write our paths as the letters we pass through. A, C, D, B. 4 plus 6 plus 1, that's going to be 11. Our next path could be A, E, F, and B. And that would be 6 plus 5 plus 1, which is going to be 11. And then we have, that's going to be 12. So if you can't count today. Then we have our final path, which would be A, G, H, B. A, G, H, B. And that's 4 plus 6 plus 2, which would also be equal to 12. Where does that leave us? As I said, we've written all of those out. Our first option, which was A, C, D, and B running over the top, 4 plus 6 plus 1, is going to be our shortest path. And we're going to write it as A, C, D, B, and then we want to say shortest is 11. Okay, we're going to work through these. Find the shortest path between A and H. I want to start, I'll get to that in a second. How do we find the shortest path? Let's start by doing it just by guessing, and then we'll see if there's a quicker way to do it. So A and H, let's have a look. We've got 4, 1, 2, and 5. So 4, 1, 2, and 5 is going to be 12. So we have a 12 option. We could go 9, 5, which is going to be 14. This 5, my apologies. 14. We've got 4, 5, which is going to be 13. And then we've got 4, 3, 4, 5. I don't think we're going to get shorter than 12. So for the first one, let's say A, C, K, I, H, which is going to be 12. C and F, we can go from, and let's check. Yep, there we go. We've got that one right. C and F, we have, where are we? C, and there's F. We could do 4, 1, 2, and 4. 4 plus 4 is 8, plus 3 is 11. We have 11. We could do 3, 4, that's 7, plus 5 is 12, plus another 5 is 17. That's a lot longer. We could do 4. No, that's really the only one we can do. C and F is 11. And our last one, I and B. Where is I? I is up here. We want to find I to B. We could do 5, 1, 2, 6, which would be 8 plus 6 is 14. Is there any shorter I? Probably not. So I and B, 14. So that was our shortest paths. There are kind of quicker ways to find these. I'll go through them in a second. So a tree, if we're talking about spanning trees, or a minimum spanning tree, a tree is a network or part of a network that contains no circuits or cycles. So if you were to look at a network and it looked something like that, that would be a circuit or a cycle because it's closed. If it looked something like this, that would be something like this, that would be a tree. A minimum spanning tree is a set of edges that connects every vertex in a network. So when we solve minimum spanning trees, we can use 2 different algorithms, prims or Kruskal's. You may have also heard of Dijkstra's. I'm not going to go over that one today. It's not super necessary. Prims or Kruskal's, and you can be asked questions on using one of them. Prim's algorithm suggests is the guy who came up with this. Prim is a guy. Kruskal, you know what? Maybe they aren't guys. Let me confirm for you right now. Prim is a person. Let's double check, because if it is a woman, that would be amazing. Prim's algorithm. I think it's maybe a man. Oh, Kruskal's algorithm. Unfortunately, I think they may be men. Yeah. Okay. Their algorithms, these guys' algorithms, basically give you ways of finding the shortest or the minimum spanning tree. So we first select the shortest edge, and then we continue by selecting the shortest attached edge with prim. So we start somewhere and we go on a path. We just pick the next shortest, next shortest, next shortest, next shortest. So how does this work in practice? I'll show you in a second. Kruskal's, we look at the graph, we find the shortest edge, we highlight it. We step back. We find the next shortest edge. We highlight that. We step back. We keep highlighting all of the shortest edges until we've created our spanning tree. So let's do an example. We're going to find the minimum spanning tree first using prims, then we're going to use Kruskal's. Prims, let's start by, the rule is we have to connect everything. We can't create a circuit or a cycle. Let's start at A. 4, 9, or 8. I'm going to go for the 4. 1, 3, or 4. Go for the 1. There's only one option, 2, 4, 5, or 5. This is where I scan ahead. I go, Let's go for this 5 because this already has a 4 over here. I'd prefer to use that than to use the 5. We have 5, 8, or 5. We have to pick one of them. Let's pick the 5. We then have to pick the 4. 2 is the next shortest. 1 is obviously shortest. We now need to connect the B. We've got 6, 8, or 13. So we come back down here and we're going to pick the 6. And we've got to get the J as well. Come back up to the J, 3 or 4. I'm going to pick the 3. That would be prims. Now we'll do Kruskal's in another color. Let's do it in orange. Let's start at A, and we start at the shortest, sorry. So highlight all the ones. 1, no, the ones, highlight all the 2s, 2, 2, no, the 2s, highlight the 3s, 3, no more 3s, highlight the 4s. Now we're not going to highlight this one because it would close it off. I've just realized I missed that 4 in my prims. We do need to connect. Oh no, we'll leave it like that because I do want to show you actually why that's a good thing. We're going to use the 4 here. We've got a 4 here, 4 here, That's it. We're going to use all the 5s. I'm going to highlight this 5. Going to highlight. I'm not going to do this one because it will close it off. And I'm not going to do this one because it will close it off. 6. And have I missed anything? No, everything's connected. Now notice how we've got a 4 for this one. And we've got a 5 for this one. This is why I stand by Kruskal's. Kruskal's is the better algorithm because you're actively highlighting all the shortest ones you can find at any one point in time. You're not moving ahead and highlighting. See here, we went, oh, well, you know, we don't want to do the 4 because we've already closed it off. We've got to do a 5 or a 5. Let's go for the 5. We didn't have to do the 5. We could have back here taken a 4. That's why I think Prims is flawed. There's probably easier ways to use Prims, in which I've done incorrectly, but I think Kruskal's is better when we talk about minimum spanning trees. Notice how I haven't formed a network. If I had closed this off, or this off, or this off, or this off, we would have a network, and it would not be a minimum spanning tree. All right, find the minimum spanning tree of the network diagram below. We're going to work through this together. Don't panic. We're going to use Kruskal's because I think it's best. Let's start by highlighting all of the 1s. 1, 1, 1, 1. And I'm just showing you, honestly, how I would do this if I was in an exam. Those are all of the 1s. Now we get the 2s, 2, 2, 2. Get all of those 2s. And you can genuinely just highlight all of them as you go, unless it's creating a network. That is all of the 2s. Let's get the 3s. 3, 3, 3, 3, 3, 3. Not this one. We don't want to create a network. Not this one. We don't want a network. And not this one. We don't want a network. That looks like all the 3s. Grab the 4s. 4, 4, 4. We're missing this being connected. We're missing this being connected. We can use that 4. And then we kind of scan ahead. We don't really need any other 4s because we just need to connect this. And there we go. That's our minimum spanning tree. That's how Kruskal's, I think, is the most efficient because it's really getting you through all of your options for every number at once instead of looking ahead. All right, we have another question here. Draw a minimum spanning tree on the following network. Okay, I'm going to do the same thing. 1, 1. Do we have any more 1s? Nope. We've got 2, 2. We then have 3. No more 3s. 4, 4, 4. No more 4s. 5. And we don't really need anything else. Look ahead. What else does it need to be connected to? We need the 6. Boom. There's our shortest minimum spanning tree. Okay, this is a practice question from a practice paper. The diagram represents a network with weighted edges. Draw a minimum spanning tree for this network and determine its length. Let's do that question first. So we're going to draw it onto the diagram. Minimum spanning tree here. Let's start with our, let's see if I can just get that off and use a pen instead. Hold on. Okay, we've got, we've got 1, no other 1s. We've got 2, 2, 2, 2, and 2. We've got a lot of 2s. And then we've got 3. And we just need to connect the 3 and everything's connected. The network is revised by adding another vertex, K. Edges A, K, and C, K have weights of 12 and 10. We see them up here. We want to find the length first. So let's go back through. 2 plus 3 plus 2 plus 2 plus 2 plus 2 plus 1 is going to be 14. So we're going to write that down here, 14. We now need to use one of these. We're obviously going to use the shortest one, and it's now 24. And C above was referencing the fact that I would have drawn it onto the sheet. Okay, so that is shortest paths and minimum spanning trees. We have about 30, about 35 minutes left, just less than that. So we're going to get through maximum flow, minimum cut, and then I'm going to have a bit of a chat to you about just a couple things about year 12 that I like to bring up, talk about issues that students have at the end. So that it might be about 15 minutes, depending on how we go with these slides. All right, so when discussing the maximum flow, we're trying to find the maximum quantity of something that we can push through a network diagram at one time. So whatever we're pushing through, so we've got water, electricity, anything, it must start at a source. And that's always going to be labeled as S, and it's going to end at the sink, and we label this T. I always like to give this to you as an example of these are the mountains, this is the dam, this is the pipes. Let's say they squiggle around everywhere. I don't know if they actually do that. They probably don't. They probably look like this. And this is your house. This is your bathroom sink. And this is you washing your hands. So your water is coming from this dam up here through all these pipes to your bathroom sink. Think about that in every example we do. In the below example, we are trying to find the maximum amount of water that we can push from the source, aka the dam, to your bathroom sink. The source always has an infinite amount of water. I want you to never forget that. Infinite amount of water at the start. In order to find the maximum flow, we're going to take into account the capacity. Think of capacity as the amount that every edge can fit. Think of this as a 6 meter pipe or a 6 liter pipe, and this is a 100 liter pipe. They're different sizes. The edge carrying S to A is a capacity of 6. So we're going to work through the flows. Let's travel from S to T via A and C. The lowest capacity is 4, so the most we can push through is 4 at any given time. We can put 6 through to here, but we're only going to be allowed to take through 4. So even though this is 9, we can only send through 4. Therefore, flow 1 is 4. This is a saturated edge as we have fulfilled its capacity. You want to note when you have room left over. So we now have 5 liters left over in this edge. Maybe we can use it later on. Flow 2, we're going to send through 7 liters here. We then send through another 7 liters here. But from here, we're only allowed to use 5 liters going this way. So we're going to send 5 liters this way. We now have another leftover 2 liters, which we can send through here. So the maximum flow of this diagram, if we add together all the water that's making it to the end, is going to be 4 plus 5 plus 2, which is going to be 11. Okay, so the maximum cut theorem, or the minimum cut theorem, so that was maximum flow. The minimum cut theory is a useful way to then check your answer. It's often quicker than what we've just done. The theory basically says the maximum flow of a diagram is equal to the minimum cut that you can make that will separate the dam from your bathroom sink. Essentially, every cut has a value. How big? It's going to cost more money to cut through this than it is to cut through this. You want to do the minimum cut. You want to cut through these ones and separate the source from the sink, and that number is going to equal the maximum flow. So cuts must completely separate the source from the sink with no other way for anything to get through. So by using the minimum cut method, you end up with the same result as if you'd found the maximum flow. If the numbers don't match, then you've done something wrong. Okay, we're going to work off that same example, which is this one here. So we've done what we did before. Now we're going to find our cut. So this is a cut here. 6 plus 7 is going to equal to 13. This is a cut here. 4 plus 8 is going to equal to 12. This is a cut here. 9 plus 2 is equal to 11. That is our minimum cut. These ones, too big. We didn't need them. Therefore, we've satisfied our question. Same as our maximum flow. All right. Another point I want to bring up before we actually talk about maximum flow again is how we look at minimum cuts. I want you to think of every cut as a road. Like this. Let's actually draw a little road on. Imagine that you have a little car. This is like the top-down view. And this is the steering wheel. And this is you. So you with a U. And this is your passenger. Let's actually do the Y to make it not as disgraceful for a tutor to say. Let's pop you in the driver's seat. If you are going up a cut, the cut is correct if it would go through the passenger side first. If it does not go through the passenger side first, the cut does not count. So if this arrow went this way and I went through the driver's side, that cut would actually only be equal to 8. It would not be cutting off 5, even though it technically looks like it's going through 5. It has to cut through the passenger side door first. So let's do this maximum flow question. We have 3 we send through here. We then send through 3 here and 3 here. We end up with 3 at the end. We then send through 8 down the bottom. We can only send through 6 on the next one, and we send through the 6 through the next bit. So we've sent through a full 6 there, and we've got 2 left over. We can send through that bottom edge, which we sent through there. Therefore, our maximum flow is 11. Our minimum cut is going to be going this way, and if we were to go up, see how both of those would go through passenger side first as well. Okay, beautiful. This is a practice question here. We have 2 practice questions and then we are done. So we are finishing quite early, so I will talk to you for a bit at the end about some of the things that I mentioned before. Start popping some questions in the chat when you are finished with the practice questions, and I'll answer those in the chat. Whereas for now, I will give you my tips and tricks over, obviously, the lecture instead of being able to talk to you. So we're going to calculate the capacity of the cut shown in the diagram and calculate the maximum flow between source and sink. Let's start by calculating the cut. Let's follow our cut from the bottom. Passenger side, driver side, passenger side. To find the capacity of this cut, we need to add 7, 5, and 11 together. The 8 does not count. 7 plus 5 plus 11 is going to give us, let me double check, 23. So the capacity of our diagram should be 23 at the end. Now let's work out our maximum flow. Let's switch colors because you have to kind of annotate when you do this. All right, we've got a source. We're going to start here. We're going to send 8 through here. This is the way I like to do it. I'm going to send 11 through here. And for now, I'm just going to erase all of this so we can kind of focus on the green. Okay, we've got 8, we've got 11. I'm now sitting here, I have 8 liters and 11 liters. I'm gonna look ahead at what I can separate out. I am going to send the full, there's really not much we can do here. I'm going to send 7 liters through to here, and I'm gonna send 1 liter through here. I have 11 liters here. I'm going to send 5 liters through here, 2 liters through here, and that leaves me with 4 liters that I have to send down here. So I can then send 5 liters down to here, but ultimately only 4 liters is getting through to here. I now have 4 liters sitting here. I'm going to send the full 4 liters, honestly, just straight to the sink. I have 5 liters and 2 liters here. I'm going to send 3 liters down here and 2 liters down here. So I can send 1 liter through to the end, and I can send, we've got, what have I done? 2 and 3. So we can then send 5 liters through to the end here. 1 plus 4 plus 5, our maximum flow is 10. So our minimum cut, therefore, must be 10 somewhere. Let's have a go at actually finding our minimum cut. How are we going to do this? We're going to try cuts until they equal 10. We could do 2 plus 12 plus 7. That's already higher than 10. We could do 5 plus 2 plus 10. That's a lot higher than 10. We could do 11, 6, and 4. Remember, the 5 won't count. But we kind of have to think about it a little bit differently because we're aiming for small numbers. So I'm going to look for all the small numbers I can. 1, 3, 2, and 4. Let's see. Passenger side, passenger side. Now the road's curved. Passenger side, passenger side. So therefore, our cut would go through there. Let me erase the stuff around it so you can see what I'm talking about. I'll draw it back on for you. No, that's not right. Hang on. That would be our cut. So that is correct though. Our capacity was 23 and our maximum flow was 10, and we've confirmed that with the cut. Okay, so we now have our second practice question. This is our last one for today. Another maximum flow and minimum cut question. So calculate the maximum flow for this network. We're going to start at the source. We're going to send 14 through here, 8 through here, and 8 through here. Now, what can we do after here? I'm going to send the full 8 right up here. No point in worrying about what we're going to do with that. I'm now going to saturate my edges. So I'm going to send 5 through here, and then I must have 9 left over. So I'm going to send 9 down to here. I now have 9 plus 8, which is 17. I can only send 16 through, 16. So 5 plus 8 plus 16, 5 plus 8 plus 16 is equal to 29. So the maximum flow. And we now want to find a cut that confirms that. 5 plus 16 plus 10 is 31. It doesn't need to be that high. 14 plus 16 is 30. It doesn't need to be that high either. We've got 5, and that goes through the correct side. 5, 7, 8, and 8. 5 plus 7 plus 8 plus 8. That's 28. So maybe that's not correct. Hold on. Unless, oh, no, yeah, no, that I am wrong. My maximum flow is wrong. What did I not send through? Hold on, let's have a look. 5 plus 9 is 14. 5, 8. Unless the answer is incorrect. Let's work off of, Now I often second guess my own answers. Let's have a look at this answer. Let's see if we can pick apart what might be incorrect here, because I don't see why I would be marking that we would be starting at 5 being left over. So let's say the only problem is though it can't be 29 because we have a smaller cut. The smallest cut I can see right now is the one I've drawn on there. There may very well be a smaller one, but that's the problem with these questions is you have to make them match. Where it says copy the network above and illustrate the maximum flow capacity is just about drawing it into a network. It's really not a question you guys need to worry about. Okay, so those are the end of our practice questions in our units. We have 20 minutes left. So I'm going to talk to you about a couple of different things that I think are important. The first is procrastination. I'm also going to talk about motivation and study tips as well, because those are kind of the 3 things I usually get in the chat when I ask people what they have problems with. So I'm going to start out with procrastination, motivation, and then where to find your resources and how to actually study for the paper, because those are the questions I get. Please pop your questions in the chat and I will happily respond to you in the chat. First things first is procrastination. That's a question I get every single time because I obviously advertise that I'm a procrastinator, and then everyone says, how do I not do it? How do I not do it? How do I not procrastinate? Procrastination is an interesting one. It is an entirely mental battle, and it's something that is, I think, in my opinion, it requires very specific approaches in combating it depending on who you are as a person. So to give you a little insight into my procrastination, I don't get stressed out about something being due until it's essentially within a few hours. So even if I have a paper coming up, it doesn't stress me out that I haven't done it because I know I'm going to get it done. Unfortunately, I've never not gotten something done, so I haven't learned that lesson yet, but I know that I'm going to get everything done. So if you're a person who is horribly stressed the whole time, then that's a little bit different. But if you're someone who knows that you don't have to start because you're not stressed yet, then it's kind of a whole nother dragon in itself. How do I deal with my procrastination? Firstly, my procrastination exists in academic forms and in personal forms. So I will procrastinate doing something really easy like paying a bill or paying, or, leaving the house. If I have somewhere to be at 10, I know it's a half an hour drive and I'm leaving at 9:30, but I'm kind of procrastinating because I want to do X, Y, and Z before I go. Or I'm procrastinating on, filling out a form that you have to do, or charging my headphones. Silly things like that. Or academically, I write most of my papers the day they're due or the day before they're due, and I do most of my work the night before it needs to be done. That is still something I honestly do, but I've worked out ways to do it where it's not impacting my ability to get good marks most of the time. Sometimes it definitely does, and I know that, but most of the time it's not impacting my ability to do well. So, number one, I think this is a really important thing to consider, and not something that you really get given as feedback when you deal with procrastination, but is number one, do you procrastinate? If so, okay, that's how you work. It's not always about solving the problem, but rather learning how to use it as part of who you are. If you are a procrastinator, maybe you are a procrastinator and that's it, and you're going to learn how to work with your procrastination. I understand that I procrastinate, and it's something that I just work with now. Secondly, if a task is going to take you less than 5 minutes, you have to do it. That's a good way to think about personal procrastination. If I have a task like enrolling in my subjects and I know it's going to take me less than 5 minutes, I just enroll in my bloody subjects. If something is really that short of a task, you just have to do it. If it's something personal like paying a bill, taking the bins out, folding some washing, 5 minutes and it's done, just do it. It's a really good rule to live by. I still live by it. I've gotten a lot of 5-minute tasks out of the way because of it. And then you don't spend like 2 weeks being annoyed about having to do something that takes 5 minutes genuinely. The other thing with that is if you are someone who struggles to kind of look at your work and is like, whoa, this is a lot. I don't know how to deal with all of this. I can actually show you an example of this. I break down my work into incredibly small tasks. And when I say small, I mean, okay, here's a midterm that I had due last term. Task number 1, reread the problem. We get a problem question for this subject. Task 2, create a document. I didn't even have to title it. The task was create document. Task 3, read forum. Task 4, annotate the question. Task 5, read the feedback from the 2022 exam. Task 6, read my teacher's tips. Class 7, make a table that was outlining my plan. Number 7, pull some information from my notes. Number 8, read this summary. Number 9, create the final table plan from notes. Then, I don't know if you can see this, I draw out, so this was 2 questions, each was 750 words. I draw out a little tracker, and as I write, I have the number of words I need to write, and I fill it in like a little timeline of how many words I've written. Things like this keep me motivated and help me from procrastinating because I can see how much work I've actually gotten done. When you have little tasks like create document, title document, create table, fill in table, it makes it so much easier to get through tasks, and you may not, you're not going to go from completing nothing to completing everything in a day. But by adding in things like this that make your tasks smaller and easier to understand and to do, it makes actually attacking the work less scary and easier for you as a student. I promise you, this has honestly changed how I work. I think it's a great way of focusing, a great way of being able to break down things so that they're achievable. And at least at the end of the day, you've ticked some stuff off. You've done more than you would have done if your task was start midterm. So that's one way that I do it. I'm not kidding. It's on like every page. This is another midterm create document. This is the next one. This is like all my tasks for the week. It's things as simple as like wash water bottle, upload slides. Like I'm making things into tiny tasks that aren't just like do the dishwasher or do all of this. It's like wash water bottle. It's as simple as that. It works in all aspects of your life. Break things down into simple tasks that will be able, I can tick that off. Sometimes I still get in the trap of writing down, do week 5 readings. And I'm like, well, there's 7 readings. Like break it down into the 7 readings so I can at least see what I've done. This is another example. I have some written submissions for a moot, a fake court trial to mark up tonight. And instead of just marking up fix appellant, fix a respondent, I've marked up every single thing that needs to be fixed on both submissions. It's a great way of thinking about your work, makes it more achievable, more to tick off. I love ticking things off. It's like my favorite pastime. That's one part of procrastination. Number 2, something like, let me pull it up. I swear by Forest, this app. It is an app that plants an imaginary tree on your phone. And once the tree starts growing, if you leave the app, the tree will die. I've never killed a tree. I don't know how. I will get any excuse to use my phone. My phone is my major reason for procrastination. That's another thing. Why are you procrastinating? For me, it's my phone. Locking it in another room doesn't really work because I still have internet access on my laptop. I'll get to that in a second. So with my phone, I pop it on, I turn Forest on, you pick a tree. I've unlocked all of these trees. They're very pretty. You pop it onto the amount of time that you want to spend focusing. You can use tags to show yourself, study, sport, other, what are you using to get off of your phone. And once it's done, you grow this beautiful little forest. This is my forest so far this year. I've planted 70 trees this year. And I can go all the way back to prove to you that I swear by it. This was my HSC year. I planted 99 trees and I focused for 50 hours and 50 minutes. And to give you it gives you great insight into how you work as a student. So in year 12, I was most focused at 6 p.m. And this year, my most focused time is 7 p.m. I know that I work, or actually no, my most focused time is 9 p.m. I know that I work a lot better at night, and often I put my work off until the night, and I've come to terms with myself on the fact that that's fine, that's how I work, and that's how I'm going to continue working. I'm not going to become an early bird who can start her work at 7 a.m. It's just not who I am. I think it's a great way of focusing. I really, really recommend it. It's like $2.99, and to be honest with you, it's so worth it. So that's Forest. Another way that I pay attention is by using people who study on YouTube. When I was in year 12, I loved 3 girls. They were called Ruby Granger, Eve Cornwell, and Unjada Jade. They're all British. They were in university or high school at the time, and they make amazing videos about them studying. I would study along with them, or just watch their videos of them studying like they do a day in the life, and it would really motivate me. And it would be I would kind of care. I'd be like, okay, you know what? I'm very lucky to do this. I'm very privileged that I get to be here having an education. And so I think that was a great way for me. Another thing that helps me, and this is kind of going into motivation as well, was being, and this is not the fun part, sometimes you have to be a bit harsh on yourself. You have to be a bit disciplined, and you have to be realistic with yourself and think, number one, how lucky are you to have this education? I used to have a thing up on my wall about how many girls in the world don't get to have an education and how lucky I was to be able to be educated. And it's a good reminder to think, you know what, snap out of it, just do the work, get over it. I know it's tough, but sometimes we do things that are hard. Hard things are part of life. But also it's about being disciplined with yourself. If there's a goal you're working towards, if there's an ATAR, a uni course, a placement, or a travel goal, something that you need this HSC or this ATAR, or you need to finish year 12 to do, that is your goal and you need to be able to work towards it. I think my goal was proving something to myself and doing something that I thought I could do, which was get a good ATAR and do well in my exams. And I proved that to myself. And I'm glad I did. But it's not the highlight of my life. It's not the best thing that's ever happened to me by any means. But it's important to me in the sense that I prove something to myself. So you want to find a reason. You need a reason that this is going to be a hard, 6 months. You need a reason that it's going to suck sometimes. And that has to be something that matters to you. Continuing on with motivation, kind of some points about burnout. I get a lot of questions about burnout. How do I deal with burnout? How do I cope? When is it coming? What happens if I don't or I do? Burnout is, for a lot of students, inevitable. I burned out about 2 weeks before the HSC. I sat on my phone for 13 hours a day and I didn't study. I barely pulled out my flashcards until the night before the exam and was like, well, I should probably learn some quotes. It is very, very important that you understand how burnout works and you consider it not as an inevitable, but as basically a punishment for overworking yourself. If you overwork yourself, if you don't listen to your body, if you don't consider where your head is at, you will burn out. I know that that's not good advice when you're only a couple weeks from trials, but it is the unfortunate truth. I can give you an anecdote from my own life. In the last couple of weeks, I've had a really, really, really heavy schedule, like 18-hour days, working, studying, obviously tutoring. I have another job. I am involved in a couple of different things with the Law Society, social life. All of these things build up, and suddenly I'm back to 6 hours a night. Or, you do that revenge bedtime thing where you work a long day and then you stay up until 2 because you just want some time to yourself or whatever it is. And I felt myself kind of burning out, and I got sick. And in the last couple of days, I just really needed a break, and I took some time off work and I slept, and I still did some work that needed to be done, but I kind of let myself just rot a little bit for a couple of days, and I feel a lot better now, and I'm getting over this cold, and I'm feeling like I'm getting back into that motivated spirit again. If I had not done that, I would have continued to burn out and would have then been stuffed for about a week instead of about 3 days. So it's very, very, very important that you listen to your body and take the warning signs it gives you, because if you do not, that will happen to you, but at a worse time. So burnout, inevitable, it's coming. For a lot of you, it won't happen, but I'm saying that you need to foresee the signs, and you need to be able to listen to your body and understand that if that burnout does arrive, you need to confront it, deal with it, instead of letting it fester and letting it continue to build up. That's my opinion on burnout. When we talk about how to study, just in our last kind of like 5 or so minutes here, what I have on the screen is a quick guide you could use in approaching trials. I know that most of you are about 4 weeks out from trials. So this is where I would say you want to get to in the next week, is have those notes finalized. For maths, it's hopefully not too many. You want to focus on having summary sheets done. For maths as well, try and get to that timed paper as soon as you can. When people ask me why I did well, I did timed practice papers all the time. Timed practice papers for everything. For maths, I did timed practice papers probably 2 or 3 times a week in the 2 weeks, 3 weeks before trials. Before that, I was just doing questions timed. But timed practice papers, I actually did them probably, maybe 6 or 7 before the trials. And I marked them every time. I liked seeing where I was going wrong, what I was doing correctly. And I think that is probably what got me such a good mark. When it comes to other subjects as well, same principle, timed practice papers is the reason I did well. Utilize your study periods if you have them, if your school provides you with study periods. What I used to do was, if I had a 50-minute study period for, let's say I wanted to use it for modern history, and I know this isn't maths related, I would genuinely run to that study period, sit down, not like a weird dash, but I would get there on time. And I would spend that 50 minutes writing an essay. And then that would be my 50-minute timed essay for the day, or timed essay for the next couple of days, whatever it was. With maths, I used to go to the library after school for a couple of hours, maybe 2 hours, and do the timed practice paper then, because they used to open the library for us after school, which is really nice. I would highly, highly, highly recommend trying to do those timed practice papers ASAP. That's what's going to get you the marks. That's why you're going to succeed. It's not going to be anything else but timed practice papers. When you do that, you're doing all the revision, but in the exam, because all the stuff you do falls away when you're not in exam conditions. Once you enter exam conditions, it doesn't matter how many times you've practiced sine, cos, tan. If you have 4 minutes left and you can't do that question in 4 minutes, doesn't matter. You're not getting the marks. That is so, so important to me. I think it's the most important thing. I know you hear it from everyone. It's really annoying. It's true. Where do you get those timed practice papers? Number one, we have Someone at Unlimited, which you get if you do private tutoring, or you can just buy a subscription yourself. We also have them on, there's plenty of resources on the ATAR Notes website that are free. You can also look up ACE HSC has great ones. Your school might have some in the library. You can look up NESA and just do the practice, for trials, just do past HSC papers, just do all of them. I would prefer, as a student, I kept the HSC papers for the actual HSC, because there is kind of a finite number of practice papers out there. So try and keep the HSC ones published by NESA and using the HSC, try and keep those for your post-trial study. But if you have to do a couple of them, do them. The only really, really important thing with that is pay attention to the year of the paper, because the syllabus has changed. So you may not necessarily need to do a paper from 12 for a subject like modern, where the syllabus has changed so massively. So important that you pay attention to that, because you might do a maths paper and be like, what is this? Or where's the networks? Networks has only been in the paper for maybe 3 or 4 years, so it's really important you don't miss out on that. Finally, on any other studying points, do you need extensive notes? No. Do you need flashcards? No. Do you need to memorize formulas? No, but also yes, you do need to know these formulas. On your reference sheet, you can see that these ones, they're not labeled. They don't tell you what a equals pi over 360 times, theta over 360 times pi r squared is. You need to know that that equals the area of a portion of a circle. It's about practice and incorporating these formulas into your practice that will allow you to remember them when you actually apply them in your exam. That is basically all I have to say. We do have a couple of minutes, but I think I'd rather leave you with a nice concise lecture than ramble on for any longer. I'm just trying to think if there's anything else that I would impart as good advice. Uni, I guess. If you're looking at early entry, I would highly recommend looking around. It's great. I applied, I got in, I didn't use it, but it was a nice backup. If you are wondering the prerequisites for your course, try and figure that out sooner rather than later, because you may need to do a bridging course. If you want a little insight into my uni journey, if it hasn't already been asked in the chat, because it does usually come up, I applied to UNSW to do a Bachelor of Politics, Philosophy, Economics. I did it for a term. I realized that I was lying to myself and I hated economics. I knew I hated economics, but I thought, no, I can like economics. I did PPE for a term. I switched from a Bachelor of PPE to a Bachelor of Arts, majoring in politics and international relations and minoring in global development. I did that for term 2 and term 3. UNSW has 3 terms in 2021. And at the end of 2021, in about September, I thought, you know what? I kind of do want to do law. I didn't do it out of high school. If you want to do law at UNSW, you have to take the LAT. You need to do that in October. Look it up if you want to do law at UNSW. Very important you don't miss that information. But I never had to do it because I transferred internally. You don't have to know anything about law to do it, by the way. This is a bit of a tangent. It's just a reasoning test. And I transferred into law, and now I've been in that degree for almost 2 years. I'm finishing up my 3rd year this year. And I love it. If you have any other questions about uni, pop them in the chat. If you have any other questions, full stop, pop them in the chat. And I can get to them in the next couple of minutes. I'll stay on the page. So just stay on the page and you'll see an answer come up. Thank you guys so much for being here with me today. Thank you for your engagement in the chat. Thank you for being so lovely. I'm sure you're lovely every time. Hopefully, I will see you in our September HSC lecture, which will be the last one that you'll need to attend if you do these lectures every time they come up. You guys have been wonderful. Best of luck. If you have any questions, pop them in the chat. I'll get to them in the next couple of minutes. You're amazing. Best of luck. You're going to kill it. Good luck with trials. Thank you so much, guys. Have a great rest of your day. Bye.